Having students memorize their multiplication tables is very important in the elementary years, but as many of you might know from your own experience or experiences of students you went to class with, there's just so many students that get through elementary school and into middle school, even high school, and actually into college and adulthood that really don't know their multiplication tables. There's actually a lot of strategies that students can gain or use, should I say, to memorize the multiplication charts. And I will say just the number one is counting by ones, counting by twos, by fours, and so on. So let's take a look at a multiplication chart that is not built, but what this is something you might have saw before on a classroom wall. Sometimes it goes up through 10 or 12. This one just goes 0 through 9. So we would fill it out. So it's where the squares meet. So in the first square, we have 0 times 0. Well, we actually know 0 times anything is 0. So this is pretty fast to fill in. And in fact, the vertical one is true as well. 0 times anything this way is 0. I apologize for the sloppy handwriting. I'm going to provide a cleaner copy later. Okay, and so then we do times 1, and 1's not so bad, right? We want to multiply 1 times 1 is 1, 1 times 2 is 2, 3, 4. Now, if you think about what we're doing on this line, you're actually counting by ones, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then if you count by twos, it's similar. 1 times 2 is 2, and then if you can count by 2 successfully, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to skip all the way down to fives because that's familiar to most of you. 1 times 5 is 5. 2 times 5 is 10. Hey, we're just counting by fives. 15, 20, 25, 30, and so on, right? The arch nemesis of many students really is the 7. If you can memorize the line of 7 or figure out that you have a student that doesn't know all of their times tables, you might identify exactly which ones they don't know. It might really be the ability to count by sevens, 7, 14, 21, 28, and so on. Well, what we're going to do is we're going to take this notion, but think about it in the other bases. Now, at first you're like, oh, wow, that seems like it's going to be pretty much similar. And it is in some sense, but the facts are completely different. We're going to use counting to get at that. Let's start off with the very smallest base, which is base 2. Now, think about if this is all the times tables you had to memorize, it would be easy, right? You have 0 times 0. I'm like, oh, that's 0. 0 times 1 is 0. 0 times 1 is 0. And then 1 times 1 is 1. That's all of the facts. Wow, it'd be so easy to memorize. That's base 2, everything right there. Okay, if you go to base 3, a little bit bigger, we still have a lot of things that we can know quickly. Multiplying by 0 is pretty easy. And then counting by ones or multiplying by ones. 1 times 1 is 1. 1 times 2 is 2. And then on the next line, we're going to count by twos. 0, 2. Here's where something changes. 2 times 2 is not 4. That's strange. It's always been 4. Remember, we are in base 3. In base 3, we only use the digits 0, 1, and 2. We don't even have a 4. But it is still 2 times. So it's this many. And we just have to count this many in base 3. So we have to know our counting. It all comes down to counting. 1, 2, 1, 0, 1, 1. And that is our answer. Now, if you were really stuck on it, you could build, a base 3 dots and boxes, right? You have 2 times. There's 2 times. Apply the rule, 3, and then you're left with 1, 1. Way too much work, though, and that's way too much work for students in elementary school. It's better, of course, obviously, to be able to count by any of the numbers 0 through 9, or actually up through 10, and even 12 once they get that mastered at the elementary levels. Let's take a look at some bigger bases. I'm going to look at bases 4 and 7 just to get a sense of it. By the way, I want to say this right now. You don't need to memorize these. Of course, these facts wouldn't help you later in life. But if you do not know all of your base 10 chart, you would want to work on that. So filling in the base 4 chart, counting by zeros, that's easy. Counting by ones. Starting off with 0, right? 1 times 0, 0, 1, 2, 3. Counting by twos, but starting with 0, 2. Once again, no 4 because there is no 4 in base 4. We only have the digits 0, 1, 2, 3. We have to know how to count in base 4. So it's 1, 2, 3, 1, 0, 1, 1, 1, 2. That's counting by twos. Now we're going to count by threes in base 4, starting with 0, 3, 3 more than 3. We have to know the counting. After 3 in base 4 comes 1, 0, 1, 1, 1, 2. And then we do 3 more than that. 1, 3, 2, 0, 2, 1. And there we go. Now, you're like, well, what if I got stuck or wanted to check? Well, I could use that last one as an example. If you wanted to check what is 3 times 3, you can always go back to thinking about the place values, right? We're in base 4. So this is the 1's place. This is the 4's place. And if we're trying to build a value of 3 3s, and we know in base 10 that that's 9, you can see that it would take 2 4s. That's a value of 8 right there, right? 2 4s is 8. And 1 more is 9. And you can see that's the number 2, 1, which is precisely what we drew in the box. But again, it's much faster to be able to count. Let's take a look at one last example, one last base. It's pretty large here, base 7, okay? Filling in the parts that we can see really easily, filling in all the zeros. We have that here along both sides. Let's recall that our digits are 0, 1, 2, 3, 3, 4, 5, and 6 in base 7. Let's go ahead and write out a little bit of the counting just to remember that as well. So we go 1, 2, 3, 4, 5, 6, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 0, 2, 1, and so on. Okay, we're going to kind of use that to count by the different numbers. So starting with line 1, counting by 1s, 1, 2, 3, 4, 5, 6, counting by 2s, 2, 4, 6. We do have those numbers here, right? Look over at those counting numbers, 2, 4, 6. We're counting by 2s, we're counting every other one. And if I already wrote out this list, you can already see the next ones, 1, 1, 1, 3, 1, 5, 2, 0, and so on. So let me just write those in. 1, 1, 1, 3, and 1, 5. We don't even get to 2, 0. Okay, now let's take a look at counting by 3s. I've already highlighted my list, so let me use a different highlighter. I thought I could get a different highlighter. Maybe I can't. So there we go. Different color. I'll use orange. All right. So let's see. Counting by 3, starting at 3, and then 1, 2, 3, 6. 1, 2, 3, 12, 1, 2, 3, 15, 1, 2, 3, 2, 1. I think I pronounced those numbers wrong. If you caught that, good. All right, so starting there, it's 3, 6, 1, 2, 1, 5, 2, 1, and then it would be 2, 2, 2, 3, 2, 4 for the last one. I'm going to expedite this just to finish off the video. So 4 times 1, 4, 4 times 2, that would be 1, 1. 4 times 3 would be 1, 5, and so on. You do the same thing for line 5 and line 6 until you have the chart filled out. I'm going to save you time. I'm going to provide a resource for you, which you can use on all of the future work. So let me show you that right now. I have a multiplication chart here I'm showing you already filled out for bases 2 through 9. All right, so all of the facts are here, kind of the facts we were working on. You'll use these as you move to the standard algorithm.